What is Node.js? Now, you might have already heard about JavaScript, right? JavaScript is one of the most famous programming languages that actually exist out there, right? Now, till now, if you have never interacted with something like Node.js, then most probably you must have interacted with JavaScript inside browsers, right? In browsers, there are a lot of functions that are available. For example, something like document dot get element by ID, something like this, document dot get elements by class name, and so on. These kind of functions you must have executed sometime now or then using JavaScript in order to manipulate your DOM. Or maybe you might have used something like a fetch request in order to download some data. Or if you are coming from some old versions of JavaScript, then you might have used something like XML HTTP request. You must have heard about set timeout, right? All of these features you might be already aware about, right? But the funny part about JavaScript is that if you will actually search any of these functions in the official documentation of JavaScript released by Ecmascript org every year, you won't find any. Why? Because JavaScript in itself is not that powerful that it can also manipulate things on browser, it can download some data and all. JavaScript is just like any other programming language. It can do a bunch of looping stuffs. It has functions, conditionals, all the basic stuff, right? But what happens behind the scene is that there is a concept of runtime. So if you already know about how asynchronously JavaScript handles asynchronous tasks, you must have been already aware about the concept of runtime. So what happens is JavaScript actually runs inside a runtime. What this runtime does is this runtime provides a lot of resources in terms of memory, in terms of architecture, in terms of a lot of external functions, using which the capability of JavaScript is actually enhanced. What do you mean by capability of JavaScript is actually enhanced? Think about it like Iron Man. Iron Man is already like Robert Downey Jr. when he plays the role of Iron Man, right? Then he's a good guy, he's very intelligent, he's a scientist, he's very rich and all. But the moment he is inside his suit, then the capabilities of the person actually improves, right? That similar thing exists here. JavaScript is also good, but when you actually execute it inside a runtime, then the capabilities of JavaScript is actually enhanced. Enhanced in terms of JavaScript gets a lot of access to a lot of runtime based features. For example, what browsers do? Browsers can actually render HTML for you, right? So JavaScript gets a functionality using which it can manipulate HTML for you, right? You can update any HTML attributes, you can update the CSS around it, do a lot of stuff directly using it. Apart from that, it gets capabilities around downloading some data, executing a timer. If you will see, there is no functionality of executing a timer directly in JavaScript. But due to the intervention of runtime, runtime provides a lot of resources, as I said, in terms of memory, in terms of architecture, in terms of functions, using which the capabilities enhance. So runtime provides these kind of functions, or you can say these kind of APIs that JavaScript has access to, and then it can actually use it. Now, it is going to be dependent on runtime, what kind of resources, what kind of architecture, what kind of function it is actually providing. You might be thinking, why do you need runtime? It's kind of like the parents that you have. When you're a small baby, you need the parents to actually help you for a lot of things. Similarly, runtime is required for JavaScript to help JavaScript in a lot of things, right? The reason why JavaScript is so versatile and has got so many tons and tons of applications is a lot due to these runtimes actually, right? Now, browser is also actually a runtime. Browser is also actually a runtime. So for example, when you see Chrome browser, you see Edge, right? You see Firefox. All of these browsers actually act as a runtime, right? every browser is a different runtime. For example, there can be a case that some features are supported in one browser, some features might not be supported in one browser, because all these browsers are separate entities altogether, right? These are separate from JavaScript. There is no standard regulation that exists. So that's why one thing that works in a certain way in Chrome may or may not work in a certain way in Firefox, right? Now, the best part is that most of these browsers provide similar set of APIs. Although, as I said, there is no compulsion, but still most of the APIs are having a very similar set of functionalities. And when you actually run JavaScript inside these runtime, then all of these capabilities are given to JavaScript. Now, if you are already aware about how JavaScript handle asynchronous tasks, then you might be already aware about something like event loop. You might be already aware about macro task queue, also called as the callback queue. You might be already aware about micro task queue, right? All of these memory architectural changes are also provided by runtime. If let's say runtime doesn't support it, maybe you won't be able to use all of these features in JavaScript, right? So runtime provides a lot of features to JavaScript, using which the versatility or the applications of JavaScript is so huge, starting from mobile phones, web applications, server-side application, machine learning, tons and tons of it, right? Now what happened is, for a very long period of time, the only runtime that existed for JavaScript were browsers, different browsers, okay? Different browsers, not one browser, different browser used to support, but mostly browser-based runtime were available. Now, if a browser-based runtime is available, then most of the features are going to be revolving around browsers, right? Their architecture might be different. Some of the APIs or functions might be different, but overall features will remain as it is. So in 2009, a person named Ryan Dahl actually released something called as Node.js. Now, a lot of budding developers think that Node.js is a framework or a library, because in a lot of advertisements, in a lot of blog posts, you will see Node.js versus Ruby on Rails, Node.js versus Laravel, Node.js versus Python Django. Whenever you see anything like this, stop reading that then and there. Why? Because Node.js is not a framework. Ruby on Rails, Laravel, Flask, all of these are frameworks. Framework means there are a lot of tasks that is already done for us for implementing web applications, right? Frameworks can be for web application, mobile application, blockchain, etc. But Node.js is not a framework. Instead, Node.js is a runtime. So what Ryan actually did in 2009 was, like, they released it in 2009. What they did was they extracted out JavaScript, the core JavaScript functionalities out of the browser runtime, and they set up a whole new runtime altogether called as Node.js, which enabled us to run JavaScript directly inside our terminal. When I say we are able to directly run it inside our terminal, that means we are able to directly run it inside our shell. And this shell can actually help us to directly interact with a lot of operating system features. For example, using the terminal, you can actually go to a file, create a file, do a lot of stuff, look at all of the process. Technically, by being able to run JavaScript outside of a browser and inside of a terminal, helped us to give all of these functionalities to JavaScript. The browser-based JavaScript cannot read your file system, but JavaScript running inside Node.js runtime, because now Node.js actually allows JavaScript to be run inside the terminal, right? So inside Node.js, you will be having access to create a file, update a file, do all kind of file manipulations with JavaScript, right? We'll talk about what features actually Node.js gives. But one thing that you have to realize is Node.js is just another runtime inside which JavaScript will run. Node.js will also provide a lot of resources to JavaScript for making it go to its full potential, right? Now, because it's different from browsers, of course, browser-based functionalities won't exist, because as I said, Node.js helped us to run JavaScript inside terminal. Now, inside terminal, you don't have any HTML, right? So there is no point of having a document.getElementById. And that's what it does. It removes all the irrelevant APIs that are now not required for you to interact with the system, and provides some new set of functions and APIs that are going to be more relevant. For example, as I said, creating or creation of file and deletion of file and updation of file and everything. So that's the concept of Node.js. That Node.js is a runtime. It provides a set of memory-based memory-based features, architectural features. It provides a lot of functions that you can actually use directly with JavaScript. You won't find it mentioned in the documentation of JavaScript, but because you are running JavaScript inside Node environment, you will get features to all of this. That's why a lot of time, if you run a JavaScript file using VS Code, you always see this command starting with something like node, right? So when you actually run a JavaScript file in VS Code, it is not running inside a browser, right? It is running on a file and you actually load the file in the RAM manually and do everything. That means you are actually running your JavaScript file in Node environment, right? That's what actually got things started with Node.js. So in a simple term, Node.js is a runtime inside which you can run JavaScript. It's similar to browser, but it doesn't provide browser-based features. Instead, it provides a lot of OS-based features. This is something that you need to know about Node.js. Now, are there any more runtime environments? Yes, there is something called as Dino. That's also, I guess, prepared by RAN only, right? That's also a runtime environment. But you don't need to learn about every runtime environment. Mostly when you are actually going to use JavaScript, either you are going to execute it in the browser or Node is going to be there, right? So I believe the basic introduction around what is Node.js, why do you actually need it, what are the capabilities of Node.js is clear to you. So let's talk about features of Node.js. The first most important feature that we should really appreciate, that it is open source, right? It is open source. Okay. This was created by Rian Dahl in 2009, right? Then brings raw JavaScript features into our terminal so that we can actually interact with OS-based features, right? So you will be able to run it inside a terminal, and from there you will be able to get access to a lot of OS-based features, right? Now, a lot of you guys might think, what is the difference between a runtime and a backend? Okay. Oh, sorry, runtime and a framework. This might be a very common doubt. That what's the difference between a runtime and a framework? Now, what's a runtime? Runtime is actually an environment that provides resources for a particular program or process to run. For example, here the program or process is JavaScript. So browsers and Node.js provide a lot of resources to JavaScript to run and actually access those resources. What is framework? Framework or library, depending on what scale you are actually working on. For example, if there is a very small library, that's called as library. If there is a very big library, that's called as a framework. You can assume framework is something like how you cook food. When you have to cook food, then you just go to the market, buy all the groceries and vegetables required and cook your food. You don't go to the farm, actually first grow your own vegetables, grow your own wheat, and then you'll start eating. That's not how you do it, right? Somebody else already realized that if someone wants to eat something, they have to go through all of this farming process and everything. That's what has been already done for you. Farmers already do this thing for you, that they bring the fresh vegetables directly to the market, and then from there you can actually buy it. So that's what framework is, or library is. They actually do a bunch of, I would say, features. They automatically provide a bunch of resources, right? Using which you can actually build a lot of products. You can actually solve a problem. For example, if you see inside most of the web applications, you will see login, logout, sign in, sign out kind of features. Now, this is so common that there are a lot of frameworks or libraries that are available for you to do a plug and play and implement an authentication system directly out of the box in your own project, right? This is what framework is. So runtime actually empowers JavaScript to run. JavaScript frameworks will help us to actually use them as a tool in order to create other features, right? This is something that you have to very carefully keep in mind. Now, using Node.js, now because you are able to actually run JavaScript in your terminal, the options are a lot. You can actually make server-side applications, server-side apps using Node.js, like Node.js as the runtime and JavaScript as the language. You can make desktop applications, right? You can make IoT based application, because now you can actually run JavaScript inside a terminal using the Node.js environment, right? So if you have, let's say, an Arduino board, or let's say you have a Raspberry Pi board, then on that board you can actually install a Linux operating system, and on that operating system you can install Node.js and then actually access a lot of features and build something out of it directly on these microcontrollers, right? So that is something that can be done. You can actually build a lot of libraries, right? So technically the available options that you can actually do using Node.js are immense. Okay. Apart from that, it doesn't give you browser-based features. Instead, it gives you something that can help you to access file system. You'll be able to access the file system, right? Then it also gives you access to things like timer. So it has its own implementation of timer, different from the timer that actually browser gives you, right? Then apart from that, you can actually see processes and runtime variables. We'll talk about runtime variables later, right? But you can actually see all of these things also, right? So Node.js actually enhance the capabilities of JavaScript now. Even if you see modern libraries like React and Angular, they are also dependent on Node.js for a very high use case, right? So that's what Node.js is. Now we'll talk about a few internals of Node.js that makes Node.js so special. And then we will also talk about some of the features that exist with Node.js in a bit more in depth. Make sense, guys? So if you are someone who has not installed Node.js till now, you can just go Google Node.js and you can go to the official website nodejs.org and you can download the latest version, or latest version is this current version. LTS is long-term support version. I would recommend you to download the long-term support version. It has lesser set of bugs. Once you have downloaded that, then you can open corresponding your own bash shell and just type node. The moment you press node, it will help you to actually open a Node.js REPL console, right? If you are able to open this Node.js REPL console, then you are good to go. Your installation is actually properly working fine. So why actually Node.js is kind of very cool? So before we actually understand about internal architecture of what actually is comprised inside Node.js, we need to understand something called as IO, input output. Now the IO operations in your computer system are kind of like expensive. Just think about one thing, no? Let's say there is a process running on, and there is an input expected from an end user, not even some other process. The input is expected from some end user. Now, end user can give the input immediately, or they might take 5 minutes to give the input, right? So the input output operation, when you are giving an output, you might have to send a signal to a printer. Now, how fast that printer is working depends on how fast you'll be able to actually give the output. So IO is kind of like one of the most expensive operations that exist inside your computer system. Now, the implementations of IO can be of two types. One can be blocking, one can be non-blocking. What do you mean by blocking? Blocking IO means that, let's say, on a particular thread, you're executing a process, and that particular process went for taking some input from a user. Now, this thread is actually blocked. Until or unless we are coming back from the end user and started executing the remaining steps, this is going to actually wait. This thread is actually going to wait. That means if you want to do some things parallelly, you might have to trigger multiple threads at the same time. Whereas that's not the case with non-blocking IO. Non-blocking IO handles things in a very different way, right? It doesn't handle things with a single thread that if there will be an IO operation, then the whole thread will be blocked. That's now how it actually handles. So non-blocking IO architecture we already know since the lecture of async.js, right? Since by the time we completed async.js, we already knew about non-blocking IO. And when I say IO, then any expensive operation also I'm also including in this. For example, reading a file is also an IO only, right? But let's say setting a timer might not be an IO. Okay. So this is something that I'm talking about, like these kind of expensive operations that might block your thread for a long period of time, because this is going to happen somewhere in the future. So what architecture we actually learned? We learned an architecture that there is something called as a set of queues that exist. There is something called as event loop, right? Then there is something called as your runtime, which actually executes your features. And then from your actual piece of code, you trigger the runtime. Meanwhile, behind the scenes, the event loop is running. If the runtime completes its feature and there is still something going on in the program, it is going to park its feature, park its callback inside the queues. I believe everyone knows this mechanism. On the same mechanism, even non-blocking IO works. Like even in Node.js, in the same mechanism, non-blocking IO works, right? So in Node.js also, there is something called as event loop. There is something called as event loop. There are a bunch of queues that you can maintain. Right? There will be a bunch of queues. For example, your macro task queue, micro task queue, and so on. Now, actually, when you say that there is a runtime, and inside the runtime, you actually send a signal to execute a feature, runtime is comprised of multiple things. As I said, it provides a lot of resources to your JavaScript. It's not just going to execute whatever instruction you have given, right? So there is something called as event demultiplexer. Now, in order to understand what is event demultiplexer, you need to first of all understand what is multiplexing and demultiplexing. So multiplexing in simple words is, let's say it's an electronics term that if you actually combine multiple signals into one, that's multiplexing. If you have one signal and you distribute that into multiple ones, that's demultiplexing, right? So technically, actually inside your runtime, there are a lot of things, right? One of them is actually this event demultiplexer. What this event demultiplexer actually does is, all of these IO operations or heavy operations or these costly operations are actually considered as event. So whenever the end application means something like JavaScript, triggers that, okay, this is a runtime feature, what it does is it actually registers a new entry inside the event demultiplexer, right? That it registers a new operation inside the event demultiplexer. And if it's a callback based application, then it also registers the handler inside it. And it starts executing the operation. It actually starts executing the operation. Meanwhile, when the operation is done, and if the application is still actually getting executed, then it doesn't halt the execution of the application. It just parks whatever was the corresponding handler for this operation inside the corresponding queues, right? Similar thing exists inside Node.js as well. You have already seen this architecture when I was explaining you promises and everything. Similar thing exists inside Node.js as well. That's what make Node.js non-blocking. So if you're writing your services inside Node.js, they are going to have a non-blocking architecture altogether, right? Now, if you actually talk about what Node.js is actually made up of, then there are a lot of things that Node.js is made up of. One of them is the V8 engine. What is V8 engine? V8, the JavaScript is the JavaScript engine developed by Google for Chrome. So Google initially developed this for Chrome, right? This V8 engine is actually responsible for understanding what syntax of JavaScript you are running and actually running JavaScript inside the corresponding runtime. Okay. Apart from that, runtime has a set of JavaScript APIs, or let's say you can say JavaScript functions, that actually exposes to JavaScript so that JavaScript can actually use all of these functions altogether. Apart from this, there is something called as libuv. Now this is something that you have to very carefully understand, right? Now every operating system, when you are implementing any when you're working with any operating system, every operating system works very differently. For example, reading a file, whether that is a blocking IO operation or a non-blocking IO operation, can be specific to operating system to operating system, right? If let's say you are running a timer, is that a blocking IO operation or a non-blocking IO operation? That can be also dependent on operating system to operating system. So if we are actually preparing a runtime, we can't rely a lot on what feature actually the operating system is giving us, because when we will ship this feature end to end to a particular customer, we can't be sure that what particular type of device they are actually using in order to execute my feature or see my product, right? So we need some kind of interface to actually generalize it or standardize it. So what I'm trying to say is, for example, let me give you an example. Now, if you try to read file system in a Linux based operating system, now in a Linux based operating system, reading a file is technically a blocking IO. Reading a file is technically a blocking IO. That means if you're actually using operating system resources and you start reading a file, that will act as a blocking input output operation. But we just discussed that we want to make sure that Node.js is non-blocking, right? It manages all of those queues, event loops and everything. But if Node.js is supporting non-blocking IO, then how Node.js is able to read a file system of a Linux-based operating system that supports blocking IO, right? So we need kind of like a standardization. Maybe in Windows, if you are reading file system, you don't have blocking IO. Maybe you have a non-blocking IO. So what I'm trying to say is that based on different operating system, based on different environments, every feature might be available in a different way. For example, inside Linux based operating system, if you have to read two files, then technically internally you have to create two threads altogether. There is no way that you can actually make it a non-blocking IO, right? But when we are writing Node.js code, we don't want this kind of hassle that some features are actually requiring us to create threads, some features are requiring us to create not threads, right? That's why you have kind of like a library called as libuv, right? So this is actually prepared by the Node.js core team. Node.js core team, right? And what it does is it makes Node compatible with all operating systems, right? It's written in C++, it's very fast. Like for example, from Node.js, if you will try to read a file in Linux based operating system, you will feel like that it's a non-blocking IO. But internally, in order to read the file, if the operating system is not supporting non-blocking IO, then internally you can't do it, right? So internally, maybe it's creating a lot of threads and everything. But as an end user of Node.js, when you will actually try to access file system in Node.js, you will feel like everything is working like a non-blocking IO. This is something that is extremely important, and it actually gives one of the most exciting features, or it actually creates the most exciting debate in the world of Node.js. So technically, libuv represents kind of like a IO binding, or it provides you low level IO based implementations in more compatible form for Node with respect to any operating system, right? So this libuv also exists inside the Node.js architecture. And apart from that, there are bindings. Right? What are bindings? Bindings are special programs that actually helps Node.js to interact with the libuv library, right? So a lot of things together actually prepares the architecture of Node.js, right? And that's the fun part. It gets the V8 engine from Chrome, which is one of the fastest running JavaScript engines. It works on cutting edge architecture. It provides a lot of APIs to JavaScript so that JavaScript can actually leverage operating system based features. You have libuv that is actually acting as an interface between the Node.js and a lot of different operating systems, and giving a consistent set of APIs to Node.js to use despite what operating system the user is actually working on. Then there are a set of bindings, right? that actually are a set of programs that can help the Node.js runtime to actually interact with libuv, right? So all of these things together actually helps us to prepare a runtime like Node.js, right? There are other runtimes as well. For example, Dino, you can actually yourself read about it, right? But Node.js is the most famous runtime. There are a lot of, I would say, startups and companies that are actually working with the Node.js runtime. So learning it actually makes a lot of sense. But I believe now you are already aware that if there will be an asynchronous operation coming up in Node, how it will handle. It will handle it in the same way how we were handling it in browsers. There are queues, there is a event loop, all of these things, right? So I hope the basic introduction around the architecture of Node.js is clear to everyone. So Node.js provides us a lot of globals. There are something called as globals inside Node.js. These are kind of like global variables that are available everywhere in every part of your code in Node.js runtime, right? These globals are important for a lot of features. Some of them are, for example, process global. So if you want to actually access the runtime, sorry, if you want to actually access the processes running, the current process that you are actually running, environment variables for that process, what is environment variable, we will learn later, right? So you can use the process global. There is something called as underscore underscore dir name, right? This is something using which you can actually access what is the current directory from which you are actually trying to execute the process, right? Then there is something called as require that helps us to require other modules. Till the time we don't cover module, you can assume that module is a concise segregated part of your code or a meaningful part of your code that you actually segregated in a particular module to modularize the whole piece of code, right? So there is something called as global. There is a global named as global also, right? So you might have heard about the window object inside browsers, right? The window object helps us to access a lot of things, right? Or the document object. These are actually globals that browsers provide you, right? Similar to that, there are globals that Node.js actually provides you. Okay. There is one global called as module. There's one global called as module, using which you can actually access the module pattern of Node.js. We'll talk about module pattern in upcoming set of parts. But my point being that these globals are extremely important. For a lot of features, these globals are actually very useful, right? One thing to note, there will be some cases where some of the globals will not be available. For example, there are cases where you cannot use underscore underscore dir name every time, right? There will be a certain set of configurations that you will be able to do in which underscore underscore dir name will not be actually available, right? So how can you actually access globals? Let me show you a demo. Now, as I mentioned that whenever you are actually going to run your JavaScript code inside VS Code, that is actually going to run inside Node environment. For example, when you do console.log hi and run it, you can see it executes your file saying node and then the path of your file. So it is actually running node environment. Also, one thing to note that console.log is also available inside Node.js. Console.log is not part of JavaScript, it's part of runtime feature. So console.log is available inside Node.js also, just like browser. The implementation might be different. Okay. I'll show you examples of where the implementations are different. Okay. But before that, for example, if you do something like console.log process, just write process, nothing more, nothing less. If you run it, you can see there is a whole JavaScript object that got printed. See, very big JavaScript object actually got printed. This is the process object. It has the access to what's the node process version, right? V8 engine version. You can see libuv library version, right? A lot of versions are actually present. You can actually access the environment variables. For example, you can do something like process.env. So there is a key value pair env. These are all the environment variables for my current process. You can actually access all of this. Apart from this, there is something called as module. There's a module global. This module global actually helps you to access the module pattern of Node.js. You can see there is a module global. It helps you with something like exports. You will see a lot of time me doing module.export, right? So that's what the module.exports come from. It's a JavaScript object, right? module.paths. So it is going to give you the paths of all available modules, right? So there is one global named as module. What is the use case of these globals? You will slowly and steadily understand. My point being is to make you aware about the fact that there exists the concept of global similar to that of browsers inside Node.js. But there is a global called as require. If you run it, you can see require is a function. See, module was an object, process was an object, require is a function. You can do console.log __ dir name. See, __ dir name is technically a string. So these globals can be string or functions or objects, multiple different things. But the only agenda is you are able to access all of them everywhere in your code. There are few corner cases in which in a few set of configurations, you won't be able to access your corresponding global. For example, __ dir name is not everywhere accessible. When I will teach you module pattern of JavaScript or technically Node.js, then you will realize that __ dir name are not available in modern modules, that is ES6 module systems, right? So there can be a corner case that for a few set of configurations, some globals are not available. But if a global is available, that is going to be available everywhere in your code at any point of time, anywhere you can actually use it, right? Now, what is console? Console actually also acts as a global object. You can actually use console anywhere at any point of time, right? And there are other globals. For example, there is something called as global only. As far as I know, you can see there is a global only altogether, right? There is a global object. Inside the global object, you have access to the functions like set interval, set timeout, queue microtask, all of these things, right? Clear immediate, set immediate. These kind of functions are available inside the global object. Now, one thing to notice, you should never try to update your global object, because this can be a catastrophe for your whole project, because you might be using, or somebody else might be using, or some third-party modules might be using any global in their code. And if you will change the meaning of the global, because they are just plain JavaScript objects or strings or something, then you might hamper execution of the other piece of code that is available out there. So these are what globals inside Node.js mean. Slowly and steadily, we will explore all of the globals. For example, when I will teach you module pattern, then 3 globals will be automatically clear to all of you. Then when we'll start actually developing our backend applications, then the process global will be clear to all of you, and so on. Now, as I said, browser is a different runtime, and every browser is a different runtime, and Node.js is a different runtime. So different runtimes can have different implementations. You might feel they're exposing same functions, but the internal implementations can be different. For example, even Chrome browser, Mozilla, and your Node.js, all of these runtimes provide you something called as set timeout that helps you to access a timer. Now, if you call set timeout inside Node environment, let's do console.log completed time. Okay. Now, set timeout is a function, right? What I want to do is, this function must be returning something. You already know that if function doesn't return something, then it still returns undefined, right? So there will be some return type of set timeout. Okay. Let's do const x is equals to this, and I'll do console.log x. So what's going to happen in line number 1? You're going to start a timer. You're going to go and tell the Node.js runtime that, hey, there is a timer that is going to come up. Take it. Whatever is the return value of that, you're going to immediately assign it to x. And then you're going to print x. After some time, when the timer gets completed, then you will print console.log completed timer. Let's run this code. The moment you run this code, can you see return type of set timeout is actually a timeout object? The return type of set timeout is actually a timeout object inside Node.js. And see, once the timer completes, it prints completed timer. If you copy the same piece of code, put it in your browser and run it. Now, can you see inside your Chrome browser, the return type of set timeout is not an object, it's a number. It's a number, right? And same thing happens after 10 seconds, you actually print it. So there is definitely some difference in the implementation, right? Now there is something called as clear interval. So if you do clear interval, for example, sorry, there is clear timeout and clear interval both. So now you can do something like clear timeout. And you can pass X. So whatever is the returned value of a particular timer, if you pass that to clear timeout, the timer breaks, like that never gets completed, it vanishes out. So now technically if you run it, you can see the program immediately turned off because you cleared the timeout. So here in Node.js, the clear timeout is actually taking a timeout object. Whereas inside browser, the clear timeout is actually taking a number to actually stop the timer. See, that's the difference, right? So different runtimes can have different implementation of the same feature. They might be executing things in an absolutely bizarre and different way. You can't generalize things, and even you can't generalize things between browsers. Maybe some browsers have implemented this in a certainly different way. All you can do is you can try to read the APIs, whatever you have in your mind, whatever is required. You can see what functionality it is giving you, how it is giving you, and then start working on it. Don't just pre-assume anything. So now we are going to talk about module patterns in Node.js. So what is a module? First of all, we need to understand what is a module. Okay. Module is a mechanism. Module is a mechanism for splitting JavaScript programs into separate manageable chunk called as module. Separate manageable chunk called as module that can be imported whenever needed, right? So you might be already aware about dry principle. In dry principle, what do? You technically try to create functions. If there is something that can be repeated again and again, you try to bind it inside a function, right? Now let's say you're technically trying to prepare a library, or there are a bunch of functions, but some set of functions are related to one task, some set of functions are related to one task, right? So what you can do is you can segregate out your piece of code in more manageable chunks that we call as modules. So for example, if I give you example with respect to other programming languages, first of all, then let's say in C++, okay, so you have a header file, right? Inside a header file, you have a bunch of code written. For example, if you do include stack, then you get a lot of codes around the stack class that is implemented in the STL. Similar thing exists here. In the stack class of STL, there will be multiple functions related to stacks, right? Now let's say you want to implement your own stack in Node.js. You know how to implement your own stack. Maybe you can implement it using linked list. But now you want to club all the functions of stacks and whatever implementation of stacks that you have, and then you want to expose it for the rest of the world, or let's say maybe for your own local project only. Now if you will start writing all of the code in one file, for example, stack you're implementing using linked list, okay, so let's think about it. If you want to kind of like prepare a stack library that a rest of the people can use, okay, and we want to have a library stack, then stack is going to be implemented using linked list, okay. Now if you will write all of the code of linked list and the stack in the same file and then use it also in the same file, it's going to be pretty dirty and pretty unmanageable. Instead, what you do is you club out all the related functions of a linked list in a separate file or a chunk, whatever you say. Separate out all the logical things of stack in a separate file or a chunk or a module, whatever you say, and then use linked list, whatever functions of linked list you need inside stacks. Once you have the stack module ready, then you can use it inside any other module wherever you want to actually use stack, okay. So it's kind of like you are preparing a very small library, or you can say we are preparing a very small manageable chunk of code. It's more for code splitting and making your code more readable, more manageable, keeping one particular piece of thing at one place. That's module part. And you will see this in multiple languages. Like in Java also you prepare a class and a library and then you import that, right? Similar thing exists here. Now, if you are already coming from a world of JavaScript, then you might have heard about something called as packages. If not, then I'll also talk about it. In order to prepare packages, we also need to prepare modules. Okay. So modules are basically for splitting your code into more chunks. For example, I can prepare a module of all sorting functions: merge sort, quick sort, bubble sort, selection sort, insertion sort, heap sort, all of these. Then I can prepare one module of all searching functions. I can prepare one module of segment tree, kind of like that, if you come from the DSA background, right? So that's what module pattern of Node.js is. So in one of the interviews at Apple, I was myself asked to prepare a module, to create a new module that can, let's say, sort an array and then bind it inside a module and, let's say, make it more reusable so that at other places of the code also I can use it. Okay. So it's kind of like asked in interviews as well, right? Now inside Node.js, in order to prepare these kind of modules, you have technically two mechanisms. You have two mechanisms to prepare module. One is the old mechanism and the traditional mechanism called as CJS, abbreviated as CommonJS modules. Another one is ESM, also abbreviated as ES6 modules. Okay. So these are the two ways majorly in which you can actually implement this moduling mechanism. Okay. Now, inside the Node.js runtime, depending on what configurations you are doing, you will see the whole project being prepared inside CJS module or ES module. Now, if I have to give you an example, considering that you come from a dev background, if you don't, then don't worry, we'll eventually see it. But if you come from a dev background, and if you have seen any React project, most of the React projects are written in ES moduling. But if you have seen any old Express project, then Express.js projects are generally written in CommonJS module. Let me even show you why an example. Okay. You might have encountered it, but never realized that why the syntax is different at both the places. So if you go to the React.js docs, okay, let's go anywhere. Okay, you'll see people doing something like export default. Then you will see people doing something like import, right? And you will see very frequently this kind of a syntax in React. This is technically happening because React is technically following ES6 moduling. Instead, if you look for a framework like Express, and if you see how the coding of Express is actually done, you can see instead of import, you will see a require like syntax. Okay, you will see a require like syntax. This require like syntax denotes that it is coming from the CommonJS moduling. Okay, so Node.js technically supports both of them. Okay, and ES6 moduling is a more modern way to actually handle things. CJS module has been there for quite some time, so a lot of legacy code is there, and it's also not anyhow bad or something. That's why both of them are technically supported. Which one to choose is a very opinionated thing. Whatever project you are working on, if you have similar projects in similar moduling structure, use it so that everyone is consistent. It's not like one project is in one moduling, one project is in one moduling, so you have a very regular context switch. So I believe that can be one good way to choose what modules to go for. Generally React projects are in ES modules, so if you want the all the latest modeling features and that's what you're learning, maybe you can even make your backend services around Express also in ES moduling, but you will see people making it in CommonJS also. So there is no hard and fast rule at all, right? But we'll try to see that how both of the moduling mechanism actually work. Okay, so what I'm going to do is, now let's see a bit of demo around CJS moduling. So let's say I'll make a new file and let me say searching.js. Okay, I'll make a new file searching.js and let's make a bunch of functions. Const linear search. Okay, iterative linear search, something like this, or let's just say search. Okay, it's going to take an array, it's going to take a value x. Okay, and then what you can do is, let's say this function just checks whether the element is present or not, and whatever element index it is present at, it just returns that. So okay, otherwise we are going to return undefined. Okay, so let's say we have a function linear search. I'll add one more function, binary search. Assuming array is sorted. Okay. If you don't know linear search or binary search, just read it. These are just two searching algorithms. I'm just writing a bunch of functions just to get an idea. If error at mid is less than x, then low is equals to mid plus 1. And we can do this as else if. At last, run undefined. Okay. So let's say we have two functions with us, linear search, binary search. Okay. So I'm assume that I'm preparing kind of like a searching module with me. Okay. Now let's say I want to actually use this module somewhere else. Okay. If I want to use this module somewhere else, for example, there is an index.js file. I want to use this module here actually. Okay. Now, how can I actually do that? This is present in this file and I have to use it in this file. If I was using it in the same file, then it was a simple function call. Now, what you can do now, as I said, there exists this module pattern. So we have a global called as module, right? There's a global that exists called as module. Okay. Using this module global, what we can do is we can actually start exporting a bunch of things. Okay. So there is something called as module.exports. And then you can export a whole object out together, right? Inside this object, you can say linear search as the function linear search and binary search as the function binary search. So let's see what's happening. So these two functions, I want to expose them for the rest of the world. If I don't want to expose binary search, I won't export it. If I want to expose both of them for the outer world, I'll export both of them. And in the export, I've just put an object. Inside the object, I have said key value pair, key value pair. Now, one shorthand that exists here is, if the key and the value are exactly same, then you can just write linear search and you can just write binary search. If the key and the value are exactly same, you can just write the same name once. It will act as a key value pair only. And now what's going to happen? This object is going to get exposed for the outer world, right? Now, in any other file, we can actually start using it. Okay. For example, const searching functions is equals to require. Then we have to give a path. I'll give a relative path. Let's say searching. So now what's going on? Now there is another module require. Sorry, there is another global require. What require does is, it's kind of like an import syntax, that whatever are the modules that you are exporting or you are exposing from the searching.js file in this particular path, I'll get all of those modules, right? Or I will get that whole module and I'll store that inside this variable. If you do console.log search functions and you run this file, you can see there is an object that is getting printed. The key of the object is linear search, and there is a function associated with it. And the other key is binary search, and there is a function associated with it. So we are able to actually get the functions of the other two modules inside our current module. Now you can see we have access to the search functions, right? Now it's very easy to now start using them. I'll do console.log. Search functions is an object. I can use the function linear search. I can pass an array. And let's say I search for 6. If you run it, you can see on the 6th index we have 6. If you search for 23, on the 5th index we have 23. Right? As simple as that. Okay. What you can do, you can actually destructure this object. This object is currently written like this, right? Then object dot whatever key value pair you want to access. If you want, you can actually destructure this object like this. You have two properties. You can get linear search. If you just want to import linear search, you can just import linear search, right? If you want to import binary search also, put a comma, and then you can do a binary search also. So both of the syntax works. You can get one object and then do a dot on that. And then otherwise you can even destructure the object. In destructuring, there is one benefit that whatever functions you actually need or whatever properties that is getting exported you need, only those properties you can actually destructure. So now you might be thinking that can you give any other name? For example, ls. You can see if you do ls here and start running the file, it will throw an error. Ls is not defined. So technically in CommonJS moduling, if you're doing something like this, right, then you have to give the same name. But you can give an alias that you don't want to say linear search everywhere, right? So you can say something like this. You assign it as a value to a key, and then you can use that key everywhere. Okay, I believe this should be doable. One second. So if you want to give an alias, like if you want to assign linear search another alias like ls, like you feel like linear search is too much to say, then ls can act as a alias for linear search like this. For example, if we are importing binary search, you can give it an alias like bs, right? So this aliasing can also actually work, right? So apart from this, one thing that I would like to show you is what is inside this module.export. What is this module.exports actually? If you do console.log, as I said, module is a global. If you see, let's print this whole global altogether. You can see this module global has an object exports. Okay, this module global has an object exports, and inside that object only we are actually allocating the value linear search and binary search. Okay, so you will find one more way of using this module.exports. Let me get some more code. So now you can see I have pasted a bunch of algorithms here. There's a partition algorithm, swap function. There is a random pivot picking algorithm. Right, this is the helper algorithm. This is quick sort that's available. There's insertion sort that's available. Okay. Sometimes you will see people doing something like this as well. You'll see module.exports dot quick sort is equals to the quick sort function. Okay. So by doing this, module.exports is an object, right? On that object, if you do a dot key equals to a value, so this key value pair gets allocated. You'll see module.exports dot insertion sort is equals to insertion sort. Something like this you can do, right? This is an applicable way. So I'll do one more thing. Let's rename this file to just quick sort. Okay. And I'll make another file sorting.js which will be having basic sorting algorithm. Okay. So let's say I'll cut insertion sort here. And let's say I'll bring a few more functions like bubble sort. Just a second. Okay. So here we go for bubble sort. And let's get selection sort as well. Okay. So what you can technically do, you can do module.exports dot bubble sort is equals to bubble sort insertion sort, and you can do module.exports dot selection sort is equals to selection sort. Okay, cool. Now in the index.js file, if you have to actually use them, you can again use them in any way. For example, const basic sorting is equals to require dot slash sorting, and now you can start doing sorting. For example, you can say basic sort dot bubble sort, and you can pass an array arr. Let's initialize this array. Let arr is equals to 5 4 3 2 1. Okay, let's comment this line. If you run it, and sorry, we called bubble sort, and let's now print arr again. After sorting, let's see if it sorts it. You can see it successfully sorts. So we can actually use bubble sort from there. And again, similar destructuring you can do. You can just get bubble sort, insertion sort, selection sort. If you just want a bunch of them, you can just get them. For example, I just want bubble sort and insertion sort. I'll just get that. Now I don't need to refer it using this variable. I can just directly refer it like bubble sort, right? So this is, again, you will see people doing something like this. Module.exports is equals to module.exports is equals to insertion sort is equals to insertion sort. And just for a shorthand, if you are technically preparing, let's say, a function expression, then you can even do something like this: selection, it's a selection, and let's say I'll cut this here, and I'll say something like this. You can even do something like this. I guess that's fairly easy to do if you know the concept of function expressions, right? So any of the syntax you will see people actually using at multiple places, right? Now sometimes instead of attaching an object with a lot of key value pairs, maybe you don't want to export a lot of key value pairs. You just want to export one function. What you can do, let's say here from here I just want to export quicksort. What I'll do, I'll just say module.exports is equals to quicksort. Now module.exports was actually an object. Now you have updated the property from an object to a function. Now it's no more an object, it's just a function. So if you want to actually use it here, you can do something like const quicksort is equals to require dot slash quicksort. Now this quicksort is technically a function because you are returning a function, right? So you can pass quicksort here, run it, and you can see it still sorts the array, right? This kind of a export is also called as a default export. This is also called as a default export. These kind of exports are also called as named export. Although the concept of named export and default export are more like I would say available in ES moduling, but still if you want to, when we will learn ES moduling and you will compare the current moduling structure with ES moduling, then you will realize that something like this is actually called as default export, something like this is actually called as a named export, but there is more to it in actual ES moduling. So now if you want to convert all of this to a ES6 moduling, there are two ways. So let me show you the official documentation, okay? So this is the official documentation for CommonJS moduling. You can see in CommonJS moduling, you have a syntax like this, right? You are requiring things like this, and you are doing module.exports if you want to export a class, whatever you want to do. How can you enable CommonJS moduling? Node.js has two module system, CommonJS and ES modules or Ecmascript modules. By default, Node.js will treat everything as a CommonJS module. So by default, if you have not done any configuration, by default, everything is a CommonJS module. Apart from that, if the file extension is CJS, then also it's a CommonJS module. If a file is with a .js extension and you configure a package.json file with the type property as CommonJS, then also it is CommonJS moduling. I'll talk about this package.json file, right? So file with an extension that is not mjs, cjs, json, .node.js, right? And where this, when the nearest parent package.json file contains a top level type this with module, those file will be recognized as a CommonJS modules only if they are being included via require. So see, what do they say? So there is something called as a package.json file. We'll create a package.json file, and it's very easy to create. In the package.json file, technically you can configure what type of moduling you want to enable. It's kind of like a JSON file. It's kind of like a JavaScript object notation only. I'll talk about JSON, but it's kind of like a JavaScript object that you mentioned there. And there is a key that you can put as type. If that key is CommonJS, then you will enable CommonJS moduling. Otherwise, default CommonJS moduling is already enabled. If you want to manually enable it, then you can do something like this. If you do type is equal to module, you see, type is equals to module, then things will start change. Let me show you. So this is Ecmascript modules. And you can see the syntax of Ecmascript module is a bit different also. But if you want to enable Ecmascript module, the author can tell the Node.js that Ecmascript modules loader should be done via .mjs file extension or the package.json type field or the input type flag. Outside those cases, Node.js will use CommonJS moduling. So in the package.json file, if the type field you mention as module, then also it will become a Ecmascript module. Otherwise, you can use something like .mjs. So let's start experimenting. Let's rename this file to index.mjs. Okay. Now, what will happen is, if let's say you still use const require, let's say you start still using const require, let's see what happens. You can see require is not defined in ES module scope. This require global, I mentioned, right, that there are globals available everywhere, but there can be corner cases. So in one particular moduling, some globals might not be available. So you can see require is not available, and they know that you are making a mistake here. Okay, then what can you do? So you can use an import based syntax. You can say import searching algo from /searching. Okay. Now, if you will try to use searching algo dot linear search. Okay. Let's comment out all of this. And if you run the code, you can see it still doesn't find it. See, it still doesn't find it, right? If you try to print console.log searching algo and run it, you can see it still doesn't find it. Why it is still not finding it? It says that you can do it by configuring things with .mjs extension, right? So what is actually going on? So now because the current file is .mjs, the other files, when you say /searching, it expects them to be mentioned with a .js syntax. If you say /searching.js, now if you run it, now you can see everything starts working absolutely fine, right? Although these files were in CommonJS export, this was a CommonJS export, but overall moduling mechanism is same, right? That you are just segregating piece of logic. So when you are actually using it, even if you are doing module.exports, no worries, you can still use it with a ES6 moduling based syntax using import. All you have to do is just mention them as .js. But let's say now you want to export also, you want to now export also as ES6 modules. So let's say we go to sorting. Now if you want to export this also as ES6 module, I'll do a renaming and I'll say this as .mjs. Now, if you do import sorting algo from /, see now it is mentioning already that here you have to mention .js or .mjs. Let's say we say /sorting.mjs. If you run it, you can see it still throws an error. Now why it throws an error? Because there is a problem inside sorting.mjs. Here we are using a CommonJS moduling based syntax. That's technically not gonna work. What you have to actually do is, you can say something like export. Whatever functions you want to export, just prepend them with an export. 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 Okay, I'll remove export from get main index. Okay, now what will happen? Now if you run this code, it still throws an error. You might feel, I'm still following. What's wrong? Okay, so now in ES modules, there is a concept of default export and named export. So when you actually do something like export function selection sort, export function bubble sort, this is named export. So if you want to actually access it, you will see, if you see the syntax here. So let me show you. You need to access it something like this. You need to destructure the named export. So it's going to kind of like give you thing like in an object, but you have to manually destructure it. That's mandatory. So let's say now if you do bubble sort, see it's automatically detect selection sort, insertion sort. VS Code is smart enough. If now you run it, see everything works fine. So when you do something like export and a function or just export a variable, that goes as a named export. The named export should also be always be referred as a destructured way when you are actually importing it. But then you might feel that what is default export and how can you actually use it? Now let's say I write one more function merge sort. Okay, let me write one more function merge sort. Let me bring that. So let's bring merge sort. Okay, so I'll bring a merge sort here. You can see there is a merge sort function that I brought. Now if you want to do a default export, you can do something like export default merge sort. Now when you have an default export, you can technically access it without destructuring anything. You will say merge sort. For example, you said something like merge sort. If you run it, see everything works fine. Because when you don't destructure anything and you just mention a variable, it expects that this variable is actually going to contain the default export. But I was not making a default export from anywhere, right? I was just doing a named export. Now, if you want both of them, post the default export, you can do bubble sort, selection sort, whatever you want. If you run it, see everything works fine. And you can just start using it anywhere, anytime you want. For example, merge sort, you call here, run it, and am I missing something in the merge sort function? Merge algorithm. I guess merge sort returns an array. Yep, it returns an array. So for merge sort, you have to do ARR is equals to this. Okay, see, it sorts the array. So this is the concept around named export and default export. Named, if you want to export multiple set of things, for example, bubble sort, selection sort, all of them kind of like in an object fashion, then you can do named exports. If you want to export one particular thing that is going to be, let's say, some major function or maybe some highlight of the overall module, then you can do default export. If you actually go to the documentation, see, a default export is provided, which is the value of the CommonJS module, right? And let's see where else they have defined it. When importing a CommonJS module, it can be reliably imported as a default export or its corresponding sugar syntax. You can see if we are importing some CommonJS module, you can actually import it like this. And let's also talk about this syntax. This is the alias. So let's talk about the alias. So here, what you can actually do is you can mention alias. For example, I don't want to use merge sort. I want to use it as ms, right? Something like this. So technically, let's see. I make a mistake. Looks good. Let's see. I guess you can't do. Oh, sorry. Let's try to do it for the named exports. Bubble sort as BS, insertion sort as IS. Okay, and now let's try BS here. Is there something? Where is this error coming? Temporary code runner. You can see this coming, and we don't want to return it because it's a bubble sort. So if you run it, see, it still sorts. So if you have to give alias here, instead of doing aliasing like with colon, you can do a as based syntax. This is relatively more closer to things like in Python, right? Also, you can do one thing if you want to get everything. For example, here we were destructuring, but it can even work without destructuring, right? So you can do something like import star as sorting, right? And then you can do sorting dot bubble sort. So inside this, when you say import star, it brings all the named exports and then club them together inside a variable sorting, which is technically going to be an object. And then you can just access the object like sorting dot bubble sort. If you run it, see, everything works fine. So it's kind of like syntactical sugar only. Whatever I'm technically telling you, it's all of it is syntactical sugar. You can just go through it. It's like different projects opt for different kind of moduling. So you will see both of the syntax coming up. So you should not feel blank. It's very easy to actually configure them. You can see just do an MJS file and you will start doing export and export default. Just do an MJS file, you can start using the import based syntax. And as I said, if you don't want to use the .mjs based syntax, there is one more way that we will talk about in a moment around package.json, using which also you can actually configure a CommonJS module or a ES module. So one thing you have to always note that if you are having a module that gives you a default export also and a named export also, so the first import is always going to be the default export, and then only you can always give the named export. These named export, for example, bubble sort can be given an alias like BS. The default export is already a single export, right? There cannot be multiple default exports. So there is no point of keeping it as an alias. So whatever name you give, it's an alias only. For example, if you see this is small m merge sort, but I'm importing it as capital merge sort. And if you run it, things start working absolutely fine, right? So you import the default export with an alias only. So no point of giving an alias to an alias. But named export has this property. Named export are imported with the exact name that is getting exported from the module. So in order to give it a shorthand, you can use alias like this in the import based syntaxes. Now, just like the modules that we are creating, there can be modules that other people have created for you, and you can even also push this for other people to use. I can show you how to push it in the next part maybe. But there are modules that are prepared by a lot of other people, right, that you can actually use yourself. Now when they are preparing modules, their modules can be dependent on some other modules, right? So there can be a whole set of module dependency that can exist, right? So for example, there is a website npm, right? What is npm? Npm is called as node package manager. Okay, so multiple modules clubbed together to form one complete end-to-end functionality is called as a package. Okay, so there are multiple packages that are available here that you can directly use. What is npm? What npm does is npm helps you to install these packages and even do dependency resolution. For example, let's say there is a package a that is dependent on some package b because it might be using the functionality of b. So but you don't know about it, right? When you will install a, it will directly manage automatic installation of package b also. So there is something called as topological sorting or the topological dependencies, right? So it will automatically do the topological sorting of all of the dependencies and install everything one by one, right? That what if, for example, there's a very famous one. If you want to install numpy, you need to install python. Or for example, if you want to install tensorflow, you need to install numpy. For installing numpy, you need to install python. It's like that, right? So there is a whole dependency graph that it can help to resolve for you. Okay, now what you can do is you can actually install any package very easily. For example, let's say there is a package called as .env. Okay, so any package you can search for, I'll talk about .env. If you want to install any package, you can just do npm install .env. Generally, if you have installed Node properly, then npm comes with it. In some installation mechanism, you have to install npm separately also. If you want to check whether you have npm in your system or not, then you can just do one thing. You can say npm -v. You can see I have a version of npm. That means npm is properly installed in my system. Okay, cool. Now what you can do, you can actually install any package anywhere you want. For example, if I copy this statement and just paste this here and press enter, what will happen is it says added one package. But if I go on VS Code, there's a hell lot that it did. It added 3 files actually. There is a node modules folder where you have actual the .env. .env is not dependent on anything else, so only .env comes up. And there are 2 more files that comes up, package log.json and package.json, right? If I will install something else, for example, there is a package called as Express. Now Express is dependent on a lot of other packages also. The moment you press enter, now if you see your node modules, your node modules is now very cluttered with a lot of packages. I never installed bytes. I never installed cookies. I never installed fresh. I just installed .env and Express, and see all of these are coming. Why all of these are coming? Because Express is dependent on all of these packages also, right? So the actual packages gets downloaded and gets stored inside a folder called as node_modules. So whenever you make a node project, you never push node modules on GitHub or whatever version control you're using, because node modules become a very heavy folder to actually push again and again, right? Then you have a package.json file. What is this package.json file? Package.json file is a one very simple file that can help you to understand metadata about your project. Metadata about your project means who this project is getting prepared for, what are the dependent packages or the dependencies of this project, are there any scripts configured for this project. So package.json technically contains a bunch of metadata regarding your corresponding project that you're preparing, right? I'll show you more power of package.json. But if you go to package log.json, this is something very interesting. In package log.json, whatever dependencies Express and .env installed, you will see listing of all of those dependencies. If you see package.json, there is just .env and Express mentioned. But in package log.json, you can see all the internal ones. For example, something called as media typer, merge descriptor, methods, everything that got installed and with what version it got installed, you can see all of that here, right? All of that here. Now the best part about package log.json is, even if you delete node modules, whatever I downloaded, I have deleted everything, and I just write the command npm install, what will happen? The same node modules folder will come up back, because whatever versions of the dependent packages were there, they are already mentioned here, right? So even if some package got upgraded, we are going to still get the same version, right? In this versioning, there is again the concept of cap and tilde. I'll talk about it later. But for the basic and the starters, you need to understand that package log.json is going to mention all the versions of the dependent dependencies, and package.json are going to mention all the major dependencies. Now, as I said, package.json can give you a lot of metadata. Okay, so you can actually prepare your own package.json, right, from very scratch. Let me show you how. So what you can do, you can execute a command npm init. What npm init does is, the moment you press npm init, it is going to create a package.json file for you. Technically saying, it helps you to create an npm project. What is an npm project? A project having a package.json file is a simple npm project. So it asks for your package name. So let's say I say CJS demo. It asks for a version if you want to put a version. Any description, some description. Okay. If you want to keep something default, you can keep it. I want to keep, let's say, entry point index.js. No test command, no git repository, no keywords. Author, let's say I'll put Sanket Singh. And you can see what it does. It's about to write this package.json file with the following content. Are you okay? I'll press enter. And see, I again have got a package.json file. Now if I do again npm install.env, see, now the same dependencies key value pair is coming up here, and node modules got installed. So JSON file is called as a JavaScript object notation file. Why JavaScript object notation? Because if you carefully see, it looks very similar to a JavaScript object. Curly braces, key colon value, right? But it's not a JavaScript file. It looks like a JavaScript object, but it is not a JavaScript file. That's why we call it as JavaScript object notation, right? And that's how you can actually start installing and downloading third-party packages for you.